class. Today we're going to talk about solving systems of linear equations. When we have a system of linear equations, we're going to have one of three possible types of solutions. The first possibility, is that we will have two lines that intersect each other at a single point. That single point then will be the solution point. So this situation will have one solution point. Remember that a point will have an x and a y. Traditionally, we will write that in parentheses using standard math notation. But sometimes the two lines do not have a solution point because they are parallel lines. Then there will be no solution because we have parallel lines. The third possibility is that both of the equations that are given will actually represent the same exact line. Sometimes it will be cleverly disguised, sometimes it will not be cleverly disguised at all. And thus, the first equation will be this line, and the second equation will be the same line over again. Then there are infinitely many solutions. And this is when we have the same line. So let's look at an example of each of these. Let's go ahead and learn by solving this system. X plus y equals minus 2 and x minus y equals minus 4. Now, we're going to solve this by elimination. If you're directed to solve by graphing or substitution, you will get the same answer as solving by elimination. So remember that whichever correct method you use, the solution point that you get, assuming there is one, should be exactly the same point. So what I'm going to do is I'm going to add the two equations together. And it may seem strange to write the word add here, but many students will accidentally subtract, especially with the numbers. So remember, we're going to add everything on top with everything on the bottom. The x's are going to be added, the y's are going to be added, we're going to bring down the equal sign, and then the numbers are going to be added. So x plus x is 2x. Y minus y is 0. And don't write anything there. 0 times y is 0, no matter what y is. So we're just going to leave that blank. Then we're adding minus 2 plus minus 4 is minus 6. Because if you borrowed $2 and then you borrow $4 more, now you owe $6 or negative 6. Now, if you have trouble coming up with a 2x, you could write a 1 here in front of each x and see that 1x plus 1x, 1 plus 1 is 2. If you can already see x plus x is 2x, that's fine, but some people have trouble with that. So if you have trouble, remember, write the 1 and if it helps you. All right. So now we have 2x is minus 6. So I would like to get the x alone to solve for x. As we are multiplying the x by 2, we want to undo multiplying by 2. So we want to divide by 2. And of course in math we do that on both sides. Divide by 2, divide by 2. And that gives us x is equal to minus 3. Now this is a number that will be part of our solution, but remember our solution will be a point, so this is only the first part of the solution. Now I'm going to choose one of the two equations. I could choose either one, so I'm just going to choose the first equation, which recall was x plus y equals minus 2, and then I'm going to replace the x with minus 3 and solve for y. So now I'm going to have to get the y alone. I'm subtracting 3 from the y, or I'm adding a negative 3. So in order to get the y alone, I need to add 3 to both sides, right? I'm undoing subtract 3, or I'm undoing add negative 3, however you want to think about it. So if I add 3 to both sides, I will get that y is equal to 1. Our solution point is always written as x comma y. So this will be x comma y. We found x first, but it doesn't matter which number we found first. We're always going to put the x first, and then the y. So this will be our solution point for this system of equations. Let's see that that's correct. This is the single point that satisfies this equation and that equation. So if we put negative 3 in the top for x, we get negative 3 plus 1. That's negative 2. Note that that equals negative 2. And if we put negative 3 in here and positive 1 in here, we get negative 3 minus 1, and that's negative 4. Can you see that it satisfies both equations? So that's important to realize. Now let's work on the graph. So we have that xy is equal to negative 3, 1. This is our solution point. So let's graph that first. We start here at 0, 0. Then along the x direction, we go negative 3. And then in the y direction, that's up or down, we go plus 1. So this is our solution point. I'm going to make a star on it. And we're going to think of that solution point as being our starred point. That is the point that's going to be on the top line, and it's going to be on the bottom line. But that's not enough to make a graph, is it? Because we're going to need another point on each line. So what we want to do is to find each y-intercept. Now, the way that we find the y-intercept for each line is we set x equal to 0 and solve for y. So let's do the first equation first. X plus y equals negative 2. We let x be 0. Then we get y is negative 2. So our intercept for the first line is, remember it's always an x and then a y. We let x be 0, so the x coordinate here will be 0, and the y is negative 2. Now, let's graph this, and then we'll find the y-intercept for the second line. So we already know that this point is on the graph, the negative 3, 1, because that was our solution point that's on the graph of each line. Now we additionally know that 0, negative 2 is on the graph of the first line. So we're going to start here at 0, we're going to go down 2, and then we're going to connect the dots. So this is the line that corresponds to x plus y equals minus 2, the line shown in black. Now let's find the y-intercept for the second line. The second line has equation x minus y is minus 4. So we have x minus y is minus 4. We are going to set x equal to 0. So we're going to replace the x with 0. And then we're going to solve for y. If minus y is minus 4, then we can divide both sides by minus 1 and get that y equals 4. Since minus 4 divided by minus 1, a minus divided by minus in the positive is positive 4. Again, our intercept will be a point x comma y. So this will be 0. Remember, we let x be 0. And then 4. And that will be the y-intercept for the second line. So remember, our point negative 3, 1 is on both lines. So we're going to consider this the first point on the new line. And then 0, we go 0 and x. And then we go up 4, starting at 0, 0, to get the point on the second line. And that line will look like this, roughly. Any questions about this? So, if you were asked to solve this by graphing, we would first find the x and the y that are the solution point. Then we can still create the supporting graph by finding the y-intercept for each line, graphing the start point and the y-intercept for the first line. So essentially when we're graphing, we first plot the start point, then we plot the first y-intercept. Then we plot the start point again, then we plot the second y-intercept. So can you see that? When we plot, we're going to go 1, 2, that's our first line, then 3, 4, and that's our second line. So if you're creating this electronically, you may need to click on the line tool, which looks like this, before you do each line. So you would click line tool, first point, second point, line tool, third point, fourth point. And that will make it the easiest possible for you to go ahead and create this graph. Now, if we think back to what we talked about before, which situation are we in terms of our system of equations? Did we get one solution, no solution, or infinitely many solutions? Notice that we got one solution point. This is the solution point shown, the solution negative 3, 1. Okay, class, so let's solve this system of linear equations. 3x plus 3y is negative 3, and y equals 2x minus 4. Even though some people might solve this one by substitution, I'm going to solve it by elimination and show you how this versatile method can be used. Now, if you love solving this by substitution, you're not wrong. That's a perfectly valid method to use. You may use it as well. Or, if you get a nice integer point with integer numbers, you can also solve it by graphing. But we're going to solve this one by elimination. So, the challenge I have here is that my x's are here, some of them are here, and some of them are here. So the first thing I'm going to do is I'm going to rewrite this equation so that all the x's are one on top of the other. And the way that I'm going to do that is that I'm going to subtract 2x from both sides on this equation. So this one I'm really not doing anything to. I'm just going to copy it over. 3x plus 3y equals minus 3. But for this one, I'm going to subtract 2x from both sides, thus giving me minus 2x plus y equals minus 4. Can you see what I did here? I subtracted 2x from this side, which gave me 0, and I subtracted 2x from this side, which gave me minus 2x plus y. Notice now the x is on top of the x, and the y is on top of the y, and the number is on top of the number. The equal signs are also aligned. This makes it much easier to solve by elimination. So now, if we just add the lines together, we're not going to get rid of either x or y. 3x minus 2x is x, and 3y plus 1y, right, that's a 1 in front of the y, if you want to think about it that way, is 4y. So neither one of those is really going to help us. So I'm going to need to multiply both sides of one of these equations by a number so that when I add the two equations together, at least the x or the y drop out. So the one that looks easiest to me is this one. If I multiply just the bottom equation by minus 3, then I'll have 3y on top and minus 3y on the bottom. So let's see what happens if we do that. The first thing I'm going to do is I'm going to transcribe this equation over. So let's just move this one over. And again, I'm not going to change the top equation at all. I'm just going to copy it over. And on the bottom equation, I'm going to multiply this. So this little x means times minus 3. Now the reason I want it to be minus is I want to be able to add these together and get 0y. So this gives me minus 3 times minus 2x is plus 6x. Minus 3 times 1y is minus 3y. And minus 3 times minus 4 equals plus 12. Let's add. Remember, when we do elimination method, we add. 3x plus 6x is 9x. 3y minus 3y is nothing, so I'm not going to write anything. I'm not going to write 0 or 0y. I'm just going to leave that part blank. And minus 3 plus 12 is 9. If 9x is equal to 9, and I divide both sides by 9, then I get x is equal to 1. We're going to take the x equals 1, and I'm going to plug it into the second equation, which we know is y equals 2x minus 4. I'm going to replace the x with 1. So I get y equals 2 times 1 minus 4. 2 times 1 is 2, and 2 minus 4 is minus 2. So our start or solution point, recall, is always in x comma y, will be 1, negative 2. This will be the point that we will graph first when we make our graph. So let's look again. Which one of these possibilities did we get? Did we get one solution point? Did we get no solution points, parallel lines, or did we get infinitely many solutions? Of course, again, we got one solution point. All right, so now let's see what that looks like in a graph. Our solution point for this system of linear equations is 1, negative 2. So let's graph that. We'll start in the xy rectangular coordinate system. We will start at 0, 0, and we'll go 1 in the x direction, and then since it's negative 2, we will go down in the y direction. I will make this a star. That is our start or our solution point. Now, in order to find a graph that represents this, we need to find the y-intercept for each of the two lines. So recall, to find the y-intercept, set x equal to 0, and solve for y. Of course, we will do that once for each line. So let's do the first line first. We have 3x plus 3y equals minus 3. Now, we'd like to set x equal to 0 So I'm going to replace this x with a 0. 3 times 0 is 0, so we get 3y is minus 3. Dividing both sides by 3, I get y is negative 1. Remember that our y-intercept will be a point, so we will not simply put the y-intercept as negative 1. It's a whole point, x comma y. We let x be 0, so this will be 0 minus 1. Now this time, let's find the second y-intercept together, and then we'll do the rest of the graph. So for the second y-intercept, we are again going to set x equal to 0 and solve for y. So here we have y is 2x minus 4, so y is equal to 2x minus 4. We're going to replace that x with 0, right, because we set x equal to 0 and solve for y. So this will be 0. 2 times 0 is 0, minus 4 is minus 4. Thus y is equal to minus 4, or our xy ordered pair for this y-intercept will be 0, minus 4. Now, let's graph this, remembering that we're going to graph the starred point, 1 minus 2, twice. So, we're going to do this first, and then this second, and then we're going to graph this point third, and then this point fourth. Remember that if we have a graphing program, we may need to click on the line tool before we start each new line. Okay, so let's do that together. We click on the line tool. We plot the first point, the starred point, 1, negative 2. Then we plot the second point, 0, negative 1. Starting here at 0, 0, we go 0 in x and down 1 in y. That will give us this, which is the graph of the first line. Then we will click on the line tool to graph our second line. We'll graph the start point again, 1, negative 2, and then we will graph 0, negative 4. So 0, negative 4 is here. We'll show this in a different color. And that will be the second line. Plus, if you were asked to solve by graphing, this would be the graph that you were expected to do. Now, what a lot of people do when they solve by graphing is they find the x and y-intercept for each line and graph those, and we could do that. When we find the y-intercept, we let x be 0 and solve for y. How would you think we'd find the x-intercept? We'd simply flip that around and instead of letting x be 0, we'd let y be 0, and instead of solving for y, we'd solve for x. So if you did that, then you would graph this point and this point. Then you would graph this point, and then the two lines would be perfectly aligned in a graphing program, and you would, boom, find out where they intersected. So the reason I mention this is that once in a while your starred point will be on the y-axis, right? It'll be like here or here. If that ever happens, then you can flip around our shortcut method, and instead of finding each y-intercept, you can find each x-intercept. Graph your starred point and the x-intercept for the first graph, then graph your starred point and the x-intercept for the second graph, and boom, you'll have a perfectly good graph. Note that you can save a lot of time solving by elimination. Or if you enjoy solving by substitution, you may do that as well. You can take this 2x minus 4, replace the y with it, and simplify this equation. If you do that, you will get the same exact answer. So remember that in math, if you do the same problem by two correct methods, your answers should be identical. Good luck!